Hello and welcome to my video about active galactic nuclei. Active galactic nuclei are found at the centers of active galaxies, which are galaxies with an unusually high amount of emission stemming from its core. Here's a diagram of an active galactic nucleus. As you can see here, the black hole at the center of the black hole, with its accretion disk and its dusty torus obscuring pretty much everything, making it hard to observe. Here's in a jet of electrons going from both poles of the black hole. On your left is an image of Carl K. Seifert, who first discovered active galaxies, or at the very least, he realized that they were, well, different, and that's hence the name Seifert galaxy, which is a subset of active galactic nuclei. On your right is NGC 4051. It's one of the first Seifert galaxies to be discovered. The way he found them was that you just saw that some spiral galaxies looked a bit different, like their nuclei was just brighter than normal. Here's a comparison between active galaxy and a very comparative twin of the active galaxy, both just being spiral galaxies. As you can see here, the emission lines on the non-active twin of the active galaxy is a lot lower, as you can see here too, with lambda representing wavelength being lower too. But as you can see here, the emission lines are a lot higher here in comparison. Now, the way we use emissions lines are that we take light and split it up into different wavelengths, and then this is routed into different sensors, which will basically give us data that we want. The absorption lines are the inverse of this, where rather than it being a bunch of different sources of light, it's a continuous stream of light with gases and other objects between that and the light. Now, what causes these emissions are the sort of black hole engine that ejects material from its poles, as you can see here, in the form of these, well, jets. There's a bunch of lines here. I'll explain them all. The narrow line region, as you can see here, it's a bunch of atoms in gas being ionized by radiation, resulting in these narrow emission lines you'll see. The obscuring torus is it's a donut, and then with a hole in the center. In the center is the black hole. It's formed in a manner similar to the accretion disk, at least it's hypothesized that way. There isn't that much known about it, and it actually hinders our ability to study active galactic nuclei quite a bit. But it's theorized to be formed from matter falling into the black hole and being heated up. Here's an example of an emission from an active galaxy. It's a pretty famous one. If you've ever seen the black hole image that took like a bunch of years, this is the same galaxy, Messier 87, and this stream of electrons is 5,000 light years long. Now, active galactic nuclei aren't just one thing, they have various different subsets. This one is NGC 1097 and is a Type 1 Seifert galaxies, with Type 2 being the other Seifert galaxy variant. Now, this is an example of a Seifert Type 2 galaxy, with this one being the Cicernus galaxy. Now, while they are very similar, the Type 2 Seifert galaxy does not have broad emission lines, as you can see here. Now, another type, which is probably a lot more popular, is quasars. They're pretty similar to Seifert galaxies in that they have like quite a bit of X-ray and luminous, although they are a lot brighter and they're also a lot older. And they also all have a torus, while the dusty torus is only present in the Seifert Type 2 while not appearing in the Seifert Type 1 galaxy. This image is of quasar 30C273. Now here's an X-ray image of a quasar. This is of quasar PKS 1127-145, taken through the Chandra radio telescope. The jet you see here, right there, is at least 1,000,000 light years long. Now, this isn't an actual image of a blazar, but it gives you the general idea in that they appear to be very powerful and energetic. However, while this is certainly true, it's not entirely true, as it's because of the fact that their emissions are directly pointed at Earth. Therefore, we see it as a lot more powerful and brighter. Now, while all the other galaxies that I've told you about thus far have been pretty similar to each other with some discrepancies, radio galaxies are pretty different. Well, for one thing, their emissions are mainly in the radio spectrum as opposed to X ray and visible light like Seyfert and quasars. The reason why this occurs is not entirely understood, but the best hypothesis is that while the electrons travel through the intergalactic medium, they encounter gases and other things, and they undergo synchrotron radiation, which is when a charged particle enters a magnetic field and then it travels in this helical path, and as it does that, it produces a lot of radiation, and yes, notably radio waves. Now, this is a dual active galactic nucleus in that it has two separate black holes as opposed to one powering its emissions. Now, the most numerous of active galaxies is a liner, which stands for low ionization narrow emission line regions, and they're weaker in radiation and emissions than the other AGNs I mentioned previously, and they also are known as low luminosity active galactic nuclei.